Thank you. Thank you for coming. I didn't really expect there'd be quite this many people, but let's see how it goes. So I'm Alec. I'm from Oakland, California. If you're wondering why am I here at PyCon Italy, it's because it seemed really friendly and I wanted to do a trip to Europe. So thanks for having me. The talk is about my experience. I've been programming in Python for about 10 years, and my experience trying to build an application that glues together a bunch of different open source libraries and hopefully has some snippets in it that are useful to you and that you can apply in your work as well. There's a lot of photos that go along with the talk that don't really have anything to do with the talk itself. So, okay, sorry. There we go. There's a lot of photos that have nothing to do with the talk itself, so just enjoy them. So I was building an app, and it's not really the focus of this talk, but it's a Celery alternative. So if any of you have used Celery, it's a distributed task execution framework. And I've used it in a lot of projects, and it kind of annoys me, but I figured I'd give a go at building my own version of it. And this is the only part of it we're really going to see. It's sort of got a UI. It's executing some code on your server asynchronously, and it's capturing the output and telling you how it worked. So the talk is about how do you build something like this? How do you glue together the different parts? And the parts in this case are a single page web app front end, a backend in Django REST framework, so basically an API server, which might also have pure API clients. So if your code wants to interact with it, it can do so via an API. You have a database, and then you have another worker server, which is executing these tasks. We're going to talk about a couple different patterns. The first is building a single page web app, and that's sort of the crux of the talk, is that there's all these different open source libraries that are really great, but there's not that much documentation about how you glue them together to make them do what you want. Then I have a couple of fun things that I've learned over the years about Linux and using PostGRES as a queuing system. And then we'll talk about testing and deploying it on Kubernetes. Okay, so the first part, single page web apps. Lots of fun, getting pretty easy these days. But gluing them together, it's not really clear how you're supposed to do it. You probably want to use, you've got a front end code base, you've got a back end code base. If you haven't used React a lot before, or if you have, you may know that, okay, this is a little my bias as a back end programmer. Webpack is super confusing. I have no idea how it works. Use create React app, and you don't have to know. So you're going to end up with a code base, front end code, back end code. On the back end, you can use Django REST framework to build your APIs. A lot of people are using something like Nginx to serve static files, but if you don't want to bother with another part of your stack, you can use a package called White Noise that will serve those files from Python for you. And one other little thing you have to figure out with a single page web app is if you're using, I don't know what they call it in JavaScript land, but fake URLs where the URLs don't actually map the files, you have to figure out how to make it so that any URL will serve the index.html page, and you can do that in White Noise as well. Let's see, so on the back end, Django REST framework, you're going to make APIs that it makes it really easy to do CRUD operations on a Django model. So if you have a database table, you can do create, update, delete on it, really straightforward. And then the last part of it is packaging it up and sharing your application. So the setup.py at the bottom here, if you ever worked with Python packaging, it can be a little bit tricky, but if you're building a web app, the thing that you really need to know about it is how to include static files. So Python packaging by default finds all the Python files in your library and includes them, but you need to give it a list of the HTML and CSS that were compiled by the front-end code to include as well. And you do that by using package data in setup.py to configure it. So let's talk a little bit about using React. If you haven't done a lot of JavaScript programming before, this might be interesting. If you are an expert, you'll be like, okay, cool. Don't worry about it. This is the basic layout of React components. So this is like an element that you're going to render onto the page, and you define a couple of things about it. An initializer, an action to run when you mount it on the page, and then how you actually want to render it. And there's a couple of tricks in here that are useful if you're making a simple app. So when you load the module onto the page, you probably want to call an API to get some state for it. And that's what's happening in component did mount. And then you're passing a callback function that says when you get the response, put it into your local storage. And then at the bottom, you're going to use that and you're going to pass it into a child element, which you're going to use to render it. So if you've done much React programming, you've probably used REDUX, which is a really fancy way to store global state. And if you're anything like me, you find that it uses a lot of boilerplate. And so I'd encourage you to skip it and pass your state around locally as much as you can. It makes your code a lot simpler to read. And hopefully it's a faster development pattern. One other, excuse me. One other note is displaying errors. If the backend fails or your API call fails, you want to show it to the user so that they see what's happening and can react to it. So let's talk a little bit about the API, the way that you call the API. This is a part that most JavaScript libraries don't talk a whole lot about because everybody wants to do it slightly differently. But you want a helper that's going to call your backend and get the data from it. And so you're going to have a helper function like this that sets some headers on it. It's passing CSRF tokens. It's passing the cookie that is your session via credentials that include. And then you probably want some basic error handling, like if everything works well, just pass the payload to the callback function. If it blows up, then you're going to get an error from the back end. Or if it really blows up and the connection was dropped or something, you want to catch the fetch error. Having a single unified place for doing all this is really useful for both capturing errors and showing them to the user, but also when you're testing that you can mock it out in a single place. And we'll talk about that a little bit more later on. That's all I want to talk about the front end side. We're going to talk now a little bit about, this is a bit of the internals of how this application works. So it's triggering a Linux process that's like a task that you're running on a server. So outside of the web request, you have some long-running thing that you want to run. And we want to connect to it and get the output that it's sending as it sends it so that the user can look at the website and see what's happening. In Linux, that's a pipe when you have a connection between processes. In Linux, sockets and file descriptors or files are all, and pipes are all very similar. They're a connection that you can read from. And what's interesting about them is that when you call read, if there's no data available to read, it's going to block your process until there is something to read. And so if you want to be monitoring multiple processes and seeing which one has data available, you need to do a little bit more tricky work. You need to ask the OS which one has data available. So this is an example of doing that. We're using the pop open command, which is like execute another process. And we're saying the output of that process, so standard out and standard error, connect them to our current process using pipes. And then keep a list of the pipes that are open and use a select function to tell us which pipe has data on it. And that's an OS level helper function that they give you. You can also use it on sockets if you have network connections. And what we have is a while loop that's going to always be running as long as we have pipes open. And it will tell us, okay, there's something to read on standard out, for example. And then from that file descriptor, you can read as much data as available. When the pipe is closed, when like your child process that you started exits, then you're going to get an empty string. And that's the signal that the pipe is closed. And the alternative to doing it, so this is like one way to do it if you want to do it all in a thread and you want to like be monitoring multiple pipes to see what incoming data there is. The alternative is you could yourself spin up many different threads. And each thread could monitor a pipe and it could just block on that read call until something is available. There's a couple other fun things in here that might be useful to you someday. One is the environment. So those are environment variables that you're setting and passing to your child process. And then the second is pre-exec function is a little Python helper where you can say, when you fork the process, run this function first before you call the main command. And what we're doing here is we're setting the process group, which is the Linux like group of process IDs. And that can be useful if, for example, you want to kill the whole process group at once. So if you want to use like the OS kill or signal commands, you can signal a whole bunch of processes at the same time if they're all in the same process group. Cool, let's talk about queues a little bit. You probably use something like Redis or RabbitMQ or Amazon's SQS. Queues are a way to like pass messages, and it's great if you have high volume that you want to use a specialized tool like that. But if you've got relatively small number of messages and you don't want to introduce another piece of infrastructure to your stack, you can build your own queue in Postgres. And this is one of the things that I love about Postgres. Okay, this is a Python conference, but Postgres is still really cool, and I bet a lot of people are using it. It has so many features, and there's so many useful things you can do. This is a really simple way to make your own queue in Postgres. You make a table, and you've got a JSON field, which is where you're storing your message, and an ID column, which is just incrementing and keeping the order of the messages. And then you have many processes, let's say, that are connecting, and they're saying, like, give me the next available message. Well, how do you do that? How do you make sure that each process only gets a different message? Like, you're not sending the same message to multiple places. You can do for update, which says lock the row, and then skip rows that are locked by other processes. So this is a really easy way to make sure that you have a queue which is at least once delivery. That means we're going to send it to one worker. That worker gets to try to process it. If we're inside a database transaction, our delete isn't actually going to be visible to other transactions until we commit. So if we finish the task and we commit, we're great, we're done, we like deleted the message. If we don't, if like the connection to the database is dropped or something kills your code and we lost where we were, then the transaction will be rolled back. And the next the next worker that connects and tries to select will get this message again. So your guaranteed delivery, you might get it more than once, but you're probably going to get it once. Cool. Next thing I wanted to talk about was testing. So there's a lot of great tools out there, obviously, these days. And I just wanted to highlight a couple things that will hopefully make your life easier if you're testing a web application like this. First is get good at mocking things. You want to compartmentalize or separate out the components of your application and do unit tests that are testing just a really small part. And on the front end side, for example, let's say you want to render a little component and just check the logic inside of that instead of like having a whole integration test of the server with the backend API server as well. You probably want to do something like this where you have a mock of that API function that we looked at the beginning of the talk. And you're saying, hey, whenever somebody calls that, just like return this object instead of calling the back. And then if you're using React, they have this test render thing, which basically renders like just that component and not any children of it into a JSON structure. That is kind of ugly, but it's really convenient to just say, hey, what changed about this component since the last time I ran the test? Another great tool that's gotten really easy to use is coverage, so seeing which lines of your code are actually under test. And all you really need to know about this is that somehow the programming world settled on Java as like the standard for this. So just Google like my tool plus JUnit, and that will be the XML format that you want to get exported as your coverage report. So JUnit is like a Java unit testing framework, and that's what everybody uses for the coverage report about which lines of code got hit. If you're using the React test suite, it's the result processor is just JUnit. If you're using PyTest for your backend code base, you're making an XML coverage report, and then you can use any of a couple different tools, one of which is CodeCov, to sort of upload it to a website and view it and see which lines of your code are under test or not. Another part of your build system is probably building artifacts that you're then going to release, and you're going to be building either a Python package or like a Docker image. And so after running your test in your build system, you probably want to have something like this. The first builds a Python package, and then if you also include that upload flag, you can upload it to PyPy. So that's a screenshot of PyPy, like that's the project that I was working on. Or if you're building a Docker image, you want to upload it to something like Quay or Docker Hub, or I can't remember what it's called, a Docker repository as well. And then after way too many years of arguing about code style, I've finally given up and like accepted the people that just think you should use a formatter, because then you never have to talk about it. So if you work in a company with more than like 2 people and you like to argue about it, just pick something. It will make your life much easier. Okay, let's talk about deploying it. We built a cool application, now we want to put it on the web. How do we do that? Well, there's everybody's favorite new tool, which is Kubernetes. And let's talk a little bit about how you can deploy your application on Kubernetes. I found it a lot easier than I thought. I think if you want to run the control plane yourself, it's a lot of work. But if you use a managed service like Google's offering, it's actually just a few commands to get started. And the first thing that you need to do is you need to make a Docker image that has your application in it. And you make a Docker image by having a Docker file, and this is a little snippet of a super simple Docker file, which says from this base image, so this is like a Linux Jessie distribution with Python installed, run this command, which pip installs something, and then add some other file. And your Docker file is going to be a little bit more complicated than that, but basically you install your code into a container. And then Kubernetes is a way to orchestrate the running of those containers. So at a glance, like what are the moving parts of this thing? Pods are your individual Docker containers that are running on a node, which is a server. And then those pods can be connected to volumes. So you can have a persistent hard disk if they need state. So in this setup, Postgres is going to have a volume attached to it, but the web servers and the workers will not. And then if you need to run multiple of them, you define what's called the deployment. So you say, like, I want to run 5 web servers. Then you want to have web traffic coming in. So you want like a load balancer. And for that, you make a service. So a service says, this port maps to this like set of pods. You're probably going to want secrets, which are like passwords for your database connection and other things. Kubernetes has a simple implementation of those as well. And then there's a control plane, which is what like runs the cluster for you. It keeps track of what pods are running, and it starts more if it needs more. It recovers from failures, things like that. So let's talk a little bit about how you deploy these things, how you get them to run. At the top, we're making the cluster. So Google makes it really easy with a couple of commands to install kubectl, which is the command line interface, and then to create a Kubernetes cluster is the second command. And then the third command is make a disk for our Postgres installation to use. And this will basically just work if you have your Google account set up already with them, which is amazing because you're spinning up a lot of infrastructure with just a couple of commands. The middle part is what defines like your application's particulars. So we're going to look inside of some of these files, but each of these create commands says like make these resources that are defined in some YAML file, and we'll look into those. But we're going to make a number of secrets. We're going to make a Postgres server, we're going to make a web server, and we're going to make a worker server. And then for Postgres and the web server, they have a port attached to them, which is what the service is, so that they're like available behind a load balancer. And then for the web server, you also have an ingress, which is a public IP address. Kubernetes makes a couple of things extremely simple compared to managing your own servers, including you can see all the running containers with get pods. You can run a command inside of one of the pods with this exec command. You can look at the logs from them, or if you want to SSH into one of the host nodes, you can do that as well. All right, what's inside of these YAML files? Let's take a look. This is the one for the web server. It is defining the name of the web server and then what is the Docker image that it's used. So in the build system, we were building and pushing to this company Quay, and here you can pull down the image that you want to use, and then you say like run this Docker container with these commands. Expose this port and limit the CPU and memory usage to whatever your desire is. The last part here is how you inject secrets. So you don't want to put into your code like what is your database connection string. You define a secret and you say put this environment variable, get it from our secrets configuration. And then we do a similar thing for Postgres. So like Postgres is going to be another Docker image that you can pull. You don't even need a custom one. There's like just standard Postgres distribution out there. And it has one other section of configuration, which is for mounting the hard disk that you defined earlier on. And what's cool about that is Kubernetes is smart, so if that server goes down and gets disconnected, it will unmount that hard disk from it, like within GCP if you're using a persistent disk, or in Amazon if you're using an EBS volume. It will disconnect the EBS volume, connect it to another server, and then launch a Docker container to run the database off of that EBS volume. That's it. That's a really simple single-page web app from start to finish. We talked about a couple of different things. We talked about how to get started with making a single-page web app and putting together Django APIs with a front-end framework like React. We talked about testing tools and some random Linux knowledge that I've gathered over the years. And then we talked about deploying it on Kubernetes and how you can run all of the different containers in an orchestrated manner that makes it really highly available and automatically restarts. And you can also configure it to like scale with load as it changes. I'd love to answer any questions if you have some. Thanks for listening. You got one over here. Thanks.
Hi there. Thank you for the talk. What are the advantages of this technique, of the Kubernetes task management over the Celery? Thank you.
Yeah, actually, I wouldn't quite say they're the same thing. So Celery is like a Python library for running Linux processes or Python code asynchronously, and that's what my application was trying to make an alternative for. Kubernetes is sort of a more generalized orchestration tool to configure and run servers, basically, and Docker containers specifically. A lot of people actually do combine them a little bit more in the way that you're talking about, so that your tasks that you're running are like a single task running in a Docker container. And if you use something like Airflow, like I think it has a plugin where you say, my task is going to run in this Docker container. You can do things like that directly on Kubernetes too, which is, I think, a very powerful tool. But in this case, I was trying to explain Kubernetes as more like a generalized platform for executing your application on, whatever it might be. Does that answer your question? No, not at all. Sorry, what did I misunderstand about it?
In your talk, there was a lot of platforms. You were talking about Redux,
Yeah.
React, Django, PostGRES, and so on. But I didn't find out what is the purpose of making task management system in Kubernetes.
Oh. The purpose is, let's say like you want to run, it's sort of like a cron replacement. Like a lot of people use cron to run a scheduled task every day at 5 o'clock. They use something like Celery or Airflow to automate that and make a website where you can see what was the output, did it succeed or did it fail. So it's a tool for that, like a visual UI for scheduled tasks or asynchronous batch processing. Thanks.
Someone else? Okay, that's all. Thank you, everyone.
Thank you.